Hello and welcome back. From our past few sessions, we are discussing about how to ingest files from cloud sources into data lakehouse. In our previous video, we have seen how to use copy into to do the same. Today, we are going to discuss about autoloaders. Now, before we start with autoloaders, if you have not seen our previous video about copy into, I would like you to go back and watch this video first. Now, what exactly is autoloader? AutoLoader is an utility that you can use in order to incrementally and efficiently process new files that are arriving in your cloud storage accounts. No, your cloud storage can be any of the three cloud providers, which is GCP, AWS, or Azure. And again, you can use autoloaders to ingest file from DBFS locations as well. Now, how does autoloader work? Autoloader exactly gives you with a structured streaming source called cloud files. Now, this behaves just like ingesting data using structured streaming. If you have seen our previous video of structured streaming, then you can easily get started with autoloaders. Autoloaders give you a benefit of ingesting data in both streaming mode and in batch mode. You just need to set the triggers accordingly. The main benefit of autoloaders is it can process your incremental files or the new arriving files within exactly one scenario. And also it can scale up to millions and millions of file ingestion per hour. And to do that, it gives us with two different file detection modes. And today we are going to understand both of them. Today, we are also going to see schema evolution mode that autoloaders provide you in order to handle different types of schema arriving in your files. Now, we are going to see all of this with examples today. We are going to read some of the files and we are going to ingest them in a delta table using autoloaders. So, without any delay, let's begin. I am in my Databricks workspace. I have already created a notebook called autoloaders and my compute is also up and running. Today, we are going to process the files using autoloaders from our volume location. And this is the same location that we have created in our previous video when we were working with copy into. Now, you can also use different locations from your cloud storage. For example, you can use ADLS locations, you can use S3 locations, and you can use GCS locations in order to process the files using autoloaders. But in our example today, we are going to use volumes. Now, under the same landing directory, we are going to create a complex structure in the form of year, month, and date. And our files are going to land under the date folders respectively. This will help us to understand how autoloaders can manage complex folder structures in order to read files incrementally from cloud storage locations. Let me just go ahead and run this cell first. It says true. It means the folders are created, right? Let me just go ahead on the left hand side and expand. Let's expand the volumes. And under landing, let me just go ahead and refresh. And we can see the autoloader input, right? Let me just expand. And we can see the year folder. And we can see the month folder. And now we can see the dates folder. And right now there are no files within this. So we are going to keep the files within the respective dates folder. And then we are going to process them using autoloaders. Now, we also need a location where we are going to save our checkpoints. AutoLoader use checkpoints in order to manage and incrementally process the files from cloud storage location. Okay, so we are going to create a folder called checkpoint, and under that there will be one more folder called AutoLoader. So let me just run this. Now let me just refresh on the left hand side, and you can see the checkpoint folder created, and under the checkpoint folder we have AutoLoaders folder. Now, we are going to read the data from this location, which is Databricks dataset, and we are going to read the files for the days accordingly. And we are going to put the files under the respective year, month, and date folder that we have already created under our volume. Now, this location is available for everyone. You can just go ahead and ingest data from this location. Let me just go ahead and copy 3 of the files for 3 of the dates. Okay, so let me just run this. Awesome, it says true. So let me just go ahead and expand on the left hand side. Now, if I refresh, you can see a file under first folder. Let me just expand the second one. You can see a file, and similarly under third there is files, right? So we have a nested structure from which we have to read the files from different dates. Okay, so this is what we are going to ingest with autoloaders today. Now that our files are at correct input location and the checkpoint directory is already created, let's go ahead and understand the different file detection modes that autoloader uses. There are 2 of them. The first one is directory listing and the second one is file notification. In case of directory listing, it uses API calls to the cloud storage location in order to detect the new files that arrive at different locations. Now, it also manages all of this within its checkpoint location using a scalable option called RocksDB. The next one is file notification. In this case, it uses a notification and a queuing service and sets it up in your cloud account. This also requires cloud elevated privileges. The reason is it will set up a queuing service in your cloud account and also a notification service. So whenever a new file arrives in your cloud storage, the notification service will put that in a queuing service, which would be consumed by the autoloaders to detect the new files arriving. Now, in both of the cases, it will use the checkpoint locations in order to provide you the exactly one scenario. Now, by default, AutoLoader uses directory listing as the option. Now, if you want to use file notification, you can just go ahead and set an option in order to do so. So now that we understand the different file detection modes, let's go ahead and write our first AutoLoader. Now, AutoLoader uses a structured streaming source called cloud files in order to process the data from cloud storage location. Now, since cloud files is a structured streaming source, we can go ahead and use spark.readStream in order to read the files from cloud storage location using AutoLoaders. So let's write our first data frame df, which we will use to read the files from cloud storage. So I'll just wrap it in first bracket, and we are going to use spark.readStream. Now, this is very similar to that of structured streaming. So we need to first provide the format. So I'll just write format, and since our format is cloud files, right? The next is the format of the cloud files. So we will use option and we will write cloud files dot format. This is the format of the files that we are going to read using cloud files. So our format is CSV. Now we can use one more option to provide the extension of the files that we are going to read. So we can just write option, and we can use an option called path globe filter. So I'll just write path globe filter, and we can provide the extension as star.csv. Now, since we have headers, we can use option called header, which is true. Now, the most important option is schema location. Now, AutoLoaders uses a location to store its schema for schema evaluation purpose. Okay, so I'll just use an option called cloud files dot schema location, and we can use the same checkpoint directory for that. So I'll just copy the checkpoint directory from top and I'll paste it here. But I'll use a /1 because we are going to run AutoLoaders multiple times. So I'm going to run the first iteration under one folder. Okay. Now we just need to provide the location from where we are going to read the file. So I'll just type load, and I'm going to provide the location from where we are going to read the file, which is our AutoLoader input, right? So I'm just going to click on this, and let me just wrap in double quotes. Now, since our folders are in nested structure, so we will use wildcard called star sys. Now, this will allow AutoLoaders to go ahead and read the files from nested structure. Okay, so let me just go ahead and run this now. Awesome. Now, if I expand the data frame that AutoLoader has read, now if you see, it has read all the columns as string. But we don't need our columns called quantity and unit price as string, because quantity would be integer and unit price can be double. So we can use one more option called schema hints. Now you can even specify schema, but there is one more beautiful option called schema hints that would allow you to specify schema only for the columns that you need. So we need to only specify the schema for unit price and quantity, right? So let me just go ahead and add that option. So I'll write cloud files dot schema hints, and we are going to use both the columns. So I'll just copy quantity from here and I'll write integer and I'll put a comma, and we need unit price to be double. So I'll just copy it and I'll paste it here and I'll just type double. Okay, so let me just go ahead and rerun this. Now if you see, it has changed the quantity to integer and the unit price to double. Okay, so we have wrote our first AutoLoaders to read the file from the location using cloud files, right? Let's go ahead and write this data frame into a delta table, and we already know how to do it. And now we are going to use our same data frame, which is df, and we are going to use the write stream method because this is a structured streaming, right? So we are going to use write stream. And now we need to provide a checkpoint location, right? Which is important for AutoLoaders to process. So I'll just use an option here and I'll use checkpoint location and I'll specify the same location. So I'll just copy it from top and I'll paste it here. Okay, so this is going to be our checkpoint location. The next option that I'm going to provide is output mode. And this is all from structured streaming. So our output mode would be append because we are going to append the data. And we are going to use a trigger. So we know how to use trigger from structured streaming, right? So the trigger would be available now. So this trigger would help us to process this structured streaming in batch mode. So once we run this, this will process all the files that is present and then it will shut down. Now you can also run this in streaming mode using processing time, but we are going to run this in batch mode. Now the next option I'll use is toTable because I want to save this in a table, right? So I'll use toTable and I'll provide the name of the table, which is dev branch invoice AL1. Okay, so this is all. But before that, what I'll do is I'll add one more column to this data frame so that we know which all files were read for which all data. So I'll just use with column and I'm going to use a name called file. And I'm going to use a hidden column which already is provided with delta tables called metadata. So I'll just write call, and I'll use that column which is metadata dot file name. Okay, so let me just go ahead and import column first. So I'll just write. Now that we are ready, let me just go ahead and run this. Awesome. Now if you see, it has started initializing a stream, and it will automatically shut down by processing all of the files. So let's just wait for it to complete. Now if you see, it has just completed the processing and it's shut down, right? So let me just go ahead and run a select star on the table. So I have to use the SQL magic command. So I'll just use %SQL and I'll rerun this. Awesome. You can see the data processed, right? All of the file names are also present here, and you can see the unit price is double, and you can see the quantity is integer. We can even write a group by in order to see that. So what I'll do is I'll just write underscore underscore file, and we will use a count. So how many data is processed per file? So I'll just write from, and I'll use the same table name, which is this, and I'll just use a group by, and I'll use the name of the field. Okay, let me just run this now again. Now you can see all of the 3 files were processed, and this was the count for all of them. So now we know how AutoLoader can process the files from different location in a cloud storage, right? So we can also see if it reads the same files again. So let me just go ahead and rerun the command again, and rerun the write command again. Now you can see it has started the stream and it just stopped. So let me just go ahead and rerun the count command again. Now you can see the count still remains same. It means none of the files were processed again. So now that we know that it processes data in exactly once, let's add one more file for a date called 4th. So what I'll do is I'll quickly copy this command and I'll add it here and I'll paste it. And let's add the 4th date CSV file to the location for 4. So let me just run this. So let me just add 5th. I think the 4th file is not present at that location. So let me just add for 5th. Awesome. It says true. So let me just refresh. And if I expand the 5th folder, you can see a file here, right? Let me just go ahead and rerun the commands again, and the write command again. Awesome, it completed. Let me just go ahead and run the count again. Awesome. Now if you see, it has added the 5th file, but the count for 1st, 2nd, and 3rd remains same. So it only processes the data incrementally. Okay, great. Now that we understand how it processes data incrementally, let's go ahead and understand how the schema evolution works with autoloaders. Now, AutoLoader gives you a benefit of handling schema that comes with your files. So there are 4 different modes that you can use in order to handle the files or the schema changes or the evolution that happens when the data arrives from your cloud storage location. So the default and the first option is add new columns. Okay, so if you have not provided any schema for the data that you read, the default mode would be add new columns. There are other modes like rescue, fail on new columns, and none. Now, add new column is the default mode. Fail on new columns is something which is pretty easy. It means if there are new columns added into the schema, your stream would fail. It would not process. So you have to go back and manually change the file or the schema at the schema location. Okay, so this is for fail on new columns. But let's understand other 3 using examples. So the default mode is add new columns, right? So since we have not specified any schema, the default mode is add new columns. So let's go ahead and see what happens if we add new schema to the files while processing it incrementally. So I have already created one file called 06. It contains new columns, state and new state. Let's go ahead and upload this in volume and process it. So I'll just go back and we are going to upload this in 06. So I'll just click on upload to volume. So I'll just drag this and paste it here. Let me just upload this. Awesome, the file is uploaded. So let me just expand and we can see the file, right? Let me just go ahead and run this. So this is complete. Let me just go ahead and run the write command now. Great. Now if you see, it has failed with an error called unknown field exception. Okay, this is what happens when the default mode is add new columns, right? So what happens when it fails? It goes back and update the schema at the location that you have provided. So this was the location where our schema is there, right? As soon as it failed, it went back to this location and added the new columns that were present in the files. Okay, so let me just go ahead and rerun this. So I'll not do anything and I'll just rerun. So now if I rerun, you can see a new column added called state. Okay, so what happened? As soon as it failed, it went back to this location and added the new column. Now if you rerun the stream, it would pass. So before that, let me just add merge schema, because our delta table requires merge schema in order to merge the schema, right? So let me just add that option here, and I'll make it true. Okay, so now this is done. Let me just rerun this. Awesome. If you see, it succeeded, right? Let me just go ahead and run the count query again. And now you can see the sixth file processed, right? Let me just go ahead and show you the column as well. So I'll just copy this query from here. I'll scroll down, I'll paste it here, and I'll make a select star. Great. So let me just scroll to right, and you can see the new column called state. Okay. So this is how the schema evolution works when your default mode is add new columns. Great. Now that we understand how the default mode, which is add new columns, work, let's go ahead and see other mode, which is rescue. Now, before that, let me just reset it. So what I'll do is I'll change the location to 2, and we will change the location here as well too, and we are going to create a new table called 2. Okay, so what I'm going to do is I'm also going to remove the sixth file that we just added. So let me just delete this volume file. Okay, we are going to read all the 4 files which are already in same schema, and then we are going to add a new file with a new schema. Okay, so let me just reprocess this, and let me just write the data. Great, it is done. Let me just go ahead and show you this. So our table is 2 now, and you can see all of the existing data, right? Let's go ahead and change the mode to rescue first. So what I'll do is I'll add a new option, and that option would be cloud files dot schema evolution mode, and that mode would be rescue. Now, what exactly is this rescue? So in this mode, whenever we have a schema change, the new columns that are added as a part of schema change are put to the extra column that you see here, which is called rescue data. Okay, so your stream would not fail. Rather, the new column or the changes would be pushed to the extra column, which is the rescue data. Okay, so let me just go ahead and sixth file again. So I'll just upload the file to volume. So the sixth file is uploaded. Let me just go ahead and rerun this. And let me just go ahead and run the write command again. So it is complete. Let me just go ahead and rerun the count. And now if you see, the sixth file is added, but the stream didn't fail, right? It is because the new column was added and it was rescued. Okay. So let me just go ahead and show you it first. So what I'll do is I'll do is 2, and let me just run this. So if I scroll to right, you can see the rescued data is still null. So let me just add a filter where rescued data is not null. Okay. So now if you see, if I scroll to right, these are all from the sixth file. And the new column which was added, which is state, is put inside the rescue data. So what it does exactly is, it does not fail your stream. Rather, it pushes it into the extra column called rescue data. In future, you can go back and retrieve the data from this column if you want to read the data, right? But it will not fail your stream at all. Okay. So now that we understand rescue data, let's go ahead and see the third option, which is none. So what I'll do is I'll reset again the table. So I'll change the AutoLoader path to 3, and again I'll change it in the bottom to 3, and I'll change the table to 3. Okay, and let me just change the option to none. Now before I do that, let me just remove the sixth file again, and let me just rerun this, and let me just rerun the write command. Okay, it completed. Let me just show you this. So what I'll do is I'll run the count command again, and you can see there is no extra data for 6. Let's go ahead and upload the sixth file again. So the file is uploaded, and you can see the file on the left hand side. Let me just go ahead and rerun the commands, and this time our mode is none. Okay, now if you see the stream processing is complete, let me just go ahead and run this SQL command, which is for count, and you can see the sixth added. So the stream didn't fail, rather the sixth file was read. But let me show you one more thing. So if I scroll up, now if you see the data frame structure here, the rescue column is missing. Okay, in case of none, the stream will not fail. Any schema change which has been done would be ignored completely. So there will be no data rescue until that is specified with the rescue column option. Okay, so right now you see the default rescue column is gone. Let me just go ahead and show you So let me just run this. And now if you see on the right hand side, there is no rescue column. Let me just add the filter for file. And now you can see all the 4 records, right? The new column is missing and it is even not rescued, right? So this is the benefit that you get with none. So if you specify the option as none, everything would be ignored. Okay, any changes in the schema would be ignored and nothing would be rescued until you specify the rescue column option manually in the options. Now, the fourth option, which is the fail on new column option, is pretty easy. So whenever there is a new column added, automatically the stream would fail. So you have to go and manually either remove the column from the files or you have to change the schema which is created at the location. Okay, let's go ahead and see that schema. So on the left hand side, I'll just expand this. So what I'll do is I'll expand the AutoLoader. And if I go to 3, you can see here underscore schemas. This is where AutoLoader manages the schema. Now, let me just expand the sources on the left hand side. If I go to 0, you can see something called RocksDB. And this is what is being used to manage exactly one's processing. And this is also scalable. It can manage millions and millions files together. Okay, so now you know how the checkpoint is being used to detect new files and also how you can use different schema evaluation mode in order to process data using autoloaders. Now, before we wrap up, till now we have been using the file detection mode, which is default, which is directory listing. Now, if you want to change the file detection mode to file notification, you need to add one option. So let me just show you the option. So we can just add an option here, which is called cloud files dot use notifications. Okay, and you can just mark it as true. So once you do this, it will no longer use the directory listing mode. Rather, it is going to use the file notification mode. But to use this mode, you need elevated privileges. As soon as you run this, AutoLoader will go back to your cloud account and will try to set up the notification service and the queuing service in your cloud account. If the user who is running this does not have privileges to do that, this command would fail. Okay, so I'm not going to show this, but this is how you can configure file notification mode if that is necessary for your project. I hope you have learned a lot about autoloaders today. Now, before I wrap up, it is very important you can go ahead and check out all the options that are available with autoloaders. There are a lot of options available that you can use with different file formats and even generic options. Autoloaders are also used for backfill options. You can go ahead and backload the data using files. You can go ahead and check out those options as well that is available in this location. Autoloaders are also used as a structured streaming source in DLTs. We are going to work with DLT from our next video, which are actually Delta Live tables. Till then, keep learning, keep growing, and keep sharing.